Hello, and welcome to the Rapamatics Institute on regular subtraction. Rapamatics Institute is a St. Paul, Minnesota-based tutoring company providing online, small group, and one-on-one tutoring. Please visit us at www.rapamaticsinstitute.com for more information about our company. There's also a contact form if you have any questions to contact us. Let's begin. As you see here, we have large subtraction problems, which look like they're very difficult to do, but what we're going to be able to do at the end of this lesson is turn every single subtraction problem into an addition problem to solve. First thing we're going to do is we're going to label the pieces of our subtraction problem. Our top part is the minuend. That's what we have, our initial value. The next yellow number is the subtrahend. That's a difficult one to say, which we're taking away from our minuend. And our answer will be called the difference. Now the first thing we're going to actually do is we're going to find the complement of the subtrahend. And that's 8454714. They're complement numbers because 1545286 plus 8454714 add up to be. These numbers here add to be their complement numbers because they're a power of 10. Now what we're going to do here is we're actually going to end up adding our complement to our minuend and subtracting the power of 10. We do that because our first two boxes here, this box here and this box here, are actually equal to each other. The reason for that is because our subtrahend is actually equal to this complement number minus this power of 10. Now we're going to solve for a minuend plus our complement number. This is the most important part of the trick. We'll see here in a second why. Now what we're demonstrating here is that this pink section right here is the summation of our minuend plus our complement, which we solved down here already. Now this blue piece and this purple piece are equal to each other. This blue piece is over here. This pink piece, we'll see, is on the right over here, but because those two parts are equal, and these 10 to the 7 pieces are equal to each other, these bottom expressions are also equal to each other, which means that all three of these equations are equal to each other, which means we now have a simple solution. We look and use this right box here to get 5171861. Now, this seems like a lot of work to do a subtraction problem, but we'll take care of that here in a second, as you'll see. What we're going to do is that if I were to approach this problem initially, and I had this right here is my problem, my minuend and my subtrahend, I'd write my complement number, this green guy here, which we found as the complement to our subtrahend over here. I'm going to add that to my minuend, get my sum, which is the same as this pink number that's growing on the right side of your screen. We have to make sure still that we take away this 10 to the 7th power to get our final answer. Let's go through another one. These will start to make a lot more sense quickly. We've labeled our pieces. We're going to find our complement numbers, our subtrahend. These are complement numbers because these two numbers here, this yellow and this green, add up to a power of 10. Now this section here and this piece down here are equal to each other. This is essentially going to be the way that we do our final trick at the end. As we've always seen, we end up dropping the -1 at the very end at the top here in our last slide. Now these two equations, the subtrahend and this green-gray piece right here, are actually equal to each other. So we turn the subtrahend into a complement minus a power of 10. Those are equal. I'm going to add our minuend and our complement to find this answer here. That's our minuend plus our complement. Now we'll see that this section right here is equal to this blue section right here. This pink guy is equal to that pink section down there, which means that these two top parts of the equation are equal to each other. These two bottom pieces are obviously equal to each other. This gray one gray 10 million and this gray 10 million down here are equal to each other. What that means is that these equations are actually equal to each other, which means that all three equations are equal to each other, which gives us our answer. So to solve this quickly, we'll take our minuend, we'll add the complement, which we found over here on our left side. That'll give us our answer here, which was the one in the pink. To make sure we still subtract our power of 10, get the final answer. Next. Again, our subtrahend, this yellow piece right here, this red bracket is equal to these red brackets down here. Now this section is equal to this section right here. The rotating pink is equal to the pink there, which means that these equations are equal to each other, which means that all three of these pieces are actually equal to each other, which is our answer. Now remember, we're going to solve quickly to turn this into an addition problem. I'll take my minuend, this guy in blue, I'll add the complement number, which we found over here on the left side, to our yellow subtrahend, add them together, get this sum up here, which is equal to this sum down here in this purple. We added that over here together already. Now we're going to make sure, though, we have to subtract our power of 10 at the very last step. And that's our final answer. Next. These are complement numbers because they add up to a power of 10. Now this subtrahend, yellow piece, is equal to this green and gray piece down here. That's why they're both in red parentheses. Now our trick, remember, becomes we add the complement for yellow number. That's why they're flashing there, because that's what we found our complement. Which actually gives us this answer up here. We'll notice something though. That summation there. We're going to subtract our 10 to the 7th power again. We have an extra 0 here in the front. The 0 isn't needed. It's not a significant digit. The 0 in the front, if there's not a number like a 1 or a 4 or an 8 before this 0, we can just drop it off the equation. So our final answer is actually 699943. Okay, let's take a quiz. Pause for a second and figure out what these answers are, and then I'll quickly go through them on the slides. I'm going to add our complement of our subtrahend, which is 291, so it's 709. Add them together and remove our 1. That's our answer. And again, actually, let's go back here really quickly. We'll see that we actually have the 1 and the 0 up here. Instead of actually doing another slide to show that removing the 0, we're just going to drop it as well with this 1. It's not needed. If we drop the 1 first, it would be 098. We realize we dropped the 0 second. Very good. Now, hopefully you did well enough in that quiz that you think you understand it. We're going to do a couple more example problems just to be sure. We find our complement numbers, which are these two numbers here that add up to a power of 10. They're complement numbers because they add up to 10 to the 7. Now remember, these two bottom equations are equal to each other because this green and blue is equal to this pink. And obviously the bottom and gray areas are equal to each other still. So these will be equal, meaning all three expressions are equal to each other, which gives us our answer. So in the shortened version of how to do this trick, we'll take our minuend, our blue, we'll add our green, which is our complement of our subtrahend, which is our yellow number, add them together. We found that sum here to the right in the upper right corner. Now if you remember to subtract our power of 10, and bam, that's our final answer. Let's do one more quiz, and we'll see if you get this or not. Now this one actually is pretty interesting because we have the 3 zeros here at the end, which means we're going to see a pattern of what happens there. It's going to be the same thing with complementary subtraction, where the zeros at the end don't make a difference, as you'll see here in a second. It's because the complement number here also has 3 zeros at the end. We're going to add those 3 zeros. We're not going to have a difference. These two numbers are complement numbers. So they add to a power of 10. The subtrahend is equal to this yellow and gray, or green and gray piece together. The last slides here. Now remember to solve, we add our complement to our minuend, add them together, we'll get our solution, which is this purple part over here. Then we have to drop the power of 10 for a final solution. These are different. Perfect. Oh, we got one more. I'll flip through this really quick here. I know this lesson's already getting kind of long. I get that, but you know what? In 15 minutes, you're going to learn how to subtract every problem in your addition problem, so it's not too shabby. The more examples, the better, in my opinion. Add our complement to our minuend, get our answer, subtract the power of 10. If my computer will decide to follow along. Very good. And these are our last problems we're going to do, so take some time. Pause for a second and try to do these yourself. Remember, you're just going to add the complement and subtract the power of 1 that appears. Your final answer. Boom, boom. 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 Remember, this 0 will be dropped off. All those zeros will be dropped off. Once the 1 goes, become insignificant. Very good. Thank you for watching. You can visit us at www.rapidmaticsinstitute.com. Again, we're a small for-profit company. Feel free to contribute or give a donation if you feel like you've learned something valuable today. Thank you so much. Enjoy your afternoon. Thank you.